Welcome back, focused learners, to another explainer. Today, we are looking at a truly monumental shift in technology. I mean, we are literally crossing the threshold from artificial intelligence that just talks to us into the era of AI that actually does things for us. We're moving from a co-pilot to an autopilot. We are stepping into the world of agentic AI. Okay, let's dive right into this by looking at what McKinsey calls the Gen AI paradox. This perfectly captures the frustration so many businesses are feeling right now. Get this, 78% of enterprises have deployed generative AI, yet roughly 80% of them report absolutely zero meaningful improvement in productivity, cost, or revenue. No way, right? Well, why is that? Because while traditional Gen AI is great at, say, writing an email or drafting some code, it just stops there. It still requires a human to prompt it, review it, and actually execute the task. It's an assistant, not a doer. To understand the solution to this paradox, we really need to draw a hard line between generative chatbots and AI agents. Think of a chatbot as reactive. You ask a question, it gives you one response based on its training data. It's single step. An AI agent, on the other hand, is proactive. You give it a big goal, and it breaks that goal down into a multi-step plan, uses tools, and automates actions to get the job done. This isn't just a smarter digital assistant, guys. This is the leap to an autonomous digital worker. So let's formally define what we're actually looking at here. Agentic AI is an autonomous computer program that perceives its environment, reasons, makes decisions, and then acts independently to achieve a predefined goal. You literally just give it the destination, and it figures out the entire route, navigating around obstacles all by itself. Anatomy of an AI agent, the biological analogy. To truly grasp how this works, we need to look under the hood. And the easiest way to understand this software architecture is actually to compare it to human biology. Every true AI agent operates on a continuous four-step loop: see, think, do, and learn. First, it sees by gathering information through a perception module, like reading a database or parsing an email. Next, it thinks. The planning module acts as the brain, reasoning and breaking complex goals into smaller steps. Then it does. The action module translates choices into commands, interacting with external software. Finally, it learns from the outcome, observing the results to improve for next time. It's a brilliant framework that really illustrates the autonomous reasoning process. But reasoning requires context, which brings us to memory. Without memory, an agent starts completely from scratch every single time you interact with it. To execute continuous workflows, an agent relies on three types of memory. Session memory is short-term. It's the current task context, like a single customer service chat. Persistent memory is long-term, using vector databases to recall historical preferences or past project decisions. And finally, there's consensus memory, which is shared information distributed among multiple collaborating agents. How an agent actually uses that memory to think can happen in a few different ways. Two major reasoning paradigms are react and rewoo. React stands for reasoning in action. It uses a think, act, observe loop, solving problems step by step and deciding what to do after every single action. It's meticulous for sure, but it can get stuck in infinite loops. So the crucial point is that the newer rewoo paradigm, reasoning without observation, solves this by anticipating the necessary tools and planning the entire workflow upfront before taking a single action. This drastically reduces computing costs and basically eliminates those infinite loop risks. Types of AI agents. Of course, not all digital brains are built exactly the same. We can actually step through a hierarchy of agent complexity. Down at the bottom, we have simple reflex agents. Think of a smart thermostat turning on the heat when it hits 65 degrees. Next up, model-based agents add memory to handle changing environments, kind of like a robot vacuum navigating around your furniture. Moving up, goal-based agents plan complex sequences to reach a target, like mapping the fastest driving route. Utility-based agents take it a step further by finding the absolute most efficient path. And finally, at the very top, we have learning agents, like an advanced e-commerce engine that constantly adapts to user behavior over time. Now, you can deploy a single agent system where one agent works independently on a fixed goal. But the real magic happens in multi-agent systems. This is where multiple specialized agents collaborate. Imagine assigning a dedicated researcher agent to find data, hand it off to a coder agent to build a script, and then have a reviewer agent QA the code. Multi-agent frameworks vastly outperform single-agent setups because they divide labor based on specialized strengths. It's just like a human team. Agents
in the real world.
Now, if this all sounds like a distant science fiction future, let me stop you right there. Agentic AI is an enterprise reality today. Now, what's really interesting about this data from the early 2026 Mayfield CXO survey is the sheer speed of adoption. 42% of enterprises already have AI agents running in live production environments. Another 30% are actively piloting them. So the experimental phase is largely over. Major businesses are actively relying on autonomous systems right now. And the infrastructure supporting this is scaling massively. As of March 2026, the Model Context Protocol, or MCP, crossed 97 million installs. MCP is the standard integration layer that allows AI agents to securely connect to external tools, databases, and APIs. It is literally the digital nervous system that lets agents interact with the rest of your company's software. The infrastructure for your future digital coworkers is already being laid. Let's look at some rapid-fire real-world success stories, starting with customer support. Klarna deployed an AI assistant across 23 markets that handled 2.3 million conversations in a single month. And it didn't just talk, it actually resolved issues. Average resolution times dropped from 11 minutes down to under 2 minutes, all while keeping customer satisfaction scores matching human agents. Over at DoorDash, they are using agentic AI to power voice support for their drivers. We are talking about hundreds of thousands of daily support calls handled by an AI that maintains conversational latency of under 2.5 seconds. That is split-second perception, reasoning, and action happening simultaneously at a massive scale, drastically reducing the need to escalate issues to human operators. And they're even writing the software of tomorrow. Anthropic's coding agent, Claude Code, can plan changes, execute commands, browse documentation, and iterate across massive codebases completely autonomously. Within 6 months of its public release, it reached a $1 billion run rate. It's driving massive enterprise revenue by serving as an autonomous code developer for teams at companies like Netflix and Spotify. Risks and guardrails. Of course, giving software the ability to act autonomously brings up a very crucial topic, governance. But it's important to understand that autonomous does not mean uncontrollable. Enterprises are implementing specific architectural safeguards for every major agentic risk. If an agent gets stuck in an infinite loop, systems use graceful interruptibility to safely cut the process. To defend against prompt injection attacks, developers use least privilege access and LLM firewalls. For unpredictability and high-stakes decisions, human-in-the-loop approvals are mandated. And to prevent AI hallucinations, agents are grounded using retrieval-augmented generation, or RAG, to pull only from verified corporate data. The guardrails are scaling right alongside the capabilities. The autonomous future. So, what does this paradigm shift mean for the future of business operations? Let's move to and see how this builds into the ultimate goal for the enterprise. Historically, your enterprise resource planning system, your ERP, was just a passive record keeper. You put data in, and later a human pulled data out to make a decision. But with agentic AI, your ERP becomes an active, autonomous central brain. It will proactively spot supply chain bottlenecks, intelligently audit financial invoices, and dynamically adjust inventory, all while strictly following your company's governance rules. Which leaves us with this final, profound question. When your enterprise systems can perceive, reason, and execute routine actions entirely for themselves, what will your human teams be freed up to do? The shift from co-pilot to autopilot isn't about replacing human ingenuity. It's about removing the friction that holds it back. Thanks for joining me on this explainer, Focused Learners. Keep exploring, keep learning, and I'll see you next time.